A block of mass m1 and m2 are attached to a massless, are attached through a massless string. And another block of mass m1, sorry, m3 is attached to mass m2 using another massless string. This second massless string is passing through a pulley such that the mass m1 can move vertically downwards under the influence of gravity. In that case, find the acceleration of each mass and tension in both strings. So that is the question that we are looking today. Okay, so first we need to do the free body diagram for all blocks. So let us take block M1 initially. So we have M1 which can move freely downwards under the influence of gravity. So the forces acting on M1 can be represented as M1G, that is the force due to gravity acting downwards, and we have the tension of the string which is holding up the mass m1, which we can represent as, let's say, T is the tension of the string. So tension is upwards and m1g is downwards. So in that case, we know that the block m1 is moving downwards. That means let's take m1g as positive downwards, m1g minus the tension of the string T is equal to the m1 times a. Okay, let's call this as equation 1. And now we need to draw the free body diagram for m2. So in the case of m2, it has tension on the string towards right, towards right, that is T, and the force which is holding it back is tension on the second string. Let us call it as T1. So in this case, we can write that T minus T1 is equal to the force on M2, or resultant motion of M2 can be calculated using this equation of motion for M2. Now, similarly, we can draw the free body diagram for M3. In the case of M3, we have only tension 1, T1 is acting on M3, that we can represent as this T1. So in the case of M3, T1 is equal to M3A. That is the equation of motion for M3. Now we have 3 equations in hand, and we can solve these 3 equations easily. So let us first rewrite the equation number 1. So we can rewrite it for tension. Okay, so let us write the equation for tension T. T is equal to m1g minus m1a, right? And we can substitute this equation for tension into equation number 2. So what we can write is m1g minus m1a minus into T1. We know that T1 is m3a. m3a is equal to m2a. That is m1g is equal to, we can take these two parts into right hand side, m1 plus m2 plus m3 times a, or the acceleration can be written as acceleration a is equal to m1 divided by m1 plus m2 plus m3 times g. So that is the expression for acceleration for each blocks. Now we need to find the expression for tension, right? We know that tension T1 is equal to M3A. That is, we have expression for A, so we can write it as M3 times M1G divided by M1 plus M2 plus M3. That is tension 1 in the first string. Now we need to find T, that is the tension in the second string. So T is equal to what we can, we know that T is equal to M1G minus M1A. That is the expression for T. Now let us substitute for A. We will get M1G minus M1 times A is M1G divided by M1 plus M2 plus M3. Now we have M1G as common factor, so we can take it out, and M1G minus M1G times 1 minus M1 divided by M1 plus M2 plus M3 is the tension. So we can rewrite it as tension T is equal to M1G times M2 plus M3 divided by M1 plus M2 plus M3. That is the expression for T. So now we have found the expression for acceleration as acceleration A is equal to M1G divided by M1 plus M2 plus M3. Expression for T1 is equal to M3 times M1G divided by M1 plus M2 plus M3, and expression for tension T is equal to M1 times M2 plus M3 divided by M1 plus M2 plus M3 times G. So we have solved this problem.